Here's number 43 from section 8.1. We're asked to use the sandwich theorem, meaning that we need to find two sequences, let's call it a B sequence and a C sequence, in which the A sequence sits between. Now, factorial, if you're not familiar or can't remember, is n times n minus 1 times n minus 2 all the way down till we get to 3, 2, 1, so on and so forth. But one of the big things is that this value is always positive. This is always a positive fraction. So we can say it is bounded on the lower end by a series that goes 0, 0, 0, 0, 0, so on and so forth. But what about on the upper end? Well, it is bounded on the upper end by 1 over n. If you can imagine, if n was, let's say, 5, this is 1/5, and this 1/5 is greater than 5 times 4 times 3 times 2 times 1, which is a denominator with it's a fraction with a much larger denominator. And that's true for every single n greater than 1. Well, what do we know? Well, we know that the limit as n approaches infinity of 0 is 0. We also know that the limit as n approaches infinity of 1 over n is also 0. And since a sub n, the 1 over n factorial, fits right between there, our conclusion is that the limit as n approaches infinity of 1 over n factorial also has to be equal to 0.